All right, Module 3, 23. So we started off using, left using division, a little bit of multiplication, but we started using our new vocabulary, factors, composite, and prime. So let's go ahead and read our I can statement. I can use division and the associative property to test for factors and observe patterns. Well, what's really cool is we saw some of those patterns yesterday. When we doubled this side, we halved this side, and it would do the same if you reversed it. So I don't know why these numbers don't match up. So let's go ahead and fix that, and then I'll be right back. There we go. All right, so list the factor pairs for 8. We've already done this once, so let's try again. 1 and 8, all of them start off with 1 in the number. Well, let's double it because it's an even number, so we can double this to 2. Well, if we double it to 2, we got to half it to 4. Double half. Well, if I doubled this again, I would get 4, and that would just be a repeat, so I can stop right there. All right, again, we're going to start off with 1 and 15. We start off with the 1 in the number. This is not an even number, so I cannot double it, but I see it ends in a 5, so I know that it has to have at least a 5 as a factor. So let's count my 5s. 5, 10, 15. So there are all my factors for 15. That's it. There are no more because I can't have an even number there. All right. Sasha says that every number in the 20s is a composite number because 2 is even. So let me type that out. So she thinks 20, 21, 22, 23, 27, 28, 29. Oop, that's a 3. So all these are in the 20s, and she says all of these are composite because the 2 is even. Amanda said there are 2 prime numbers in the 20s. Who is correct? Well, let's look at Sasha's theory. Well, this 2 does not make these numbers even. Well, I'm going to circle the ones I know are composite because they are truly even. Because to find out, you would look at the end. 0, 2, 4, 6, 8. All of those I know for a fact are composite because they are even. Well, let's try this one. We know it can be 2, so let's try by our 3s. 3, 6, 9, 12, 15, 18, 21. Cool. 24, 27. Count it up, 30. It's not over here. Whew, we got rid of 2. And I'm actually going to highlight these in green because we knew they were composite because they were by 3s. There's one more I can knock out. It's this 25 right here. Because if it ends in a 5 or a 0, it has to be divisible by 5. So let's look at what Amanda said. So we know Sasha's wrong because the rest of them we won't be able to get to. They're prime. Amanda said there are 2 prime numbers in the 20s. So I would say Amanda is right. I know this because if you find the factors of all the 20s, you will see that 23 and 29 are prime. Ha, that rhymed. 23 and 29 are prime. Alright, sorry. I probably won't stop, so I'm not even going to promise that I will. So that's how I would say it. But fortunately, we don't have to write it because it was just our work it together problem. Work it. Told you, I promise I'm not going to stop. Alright, so this is our becoming independent work. Normally this is where you would do it, but because this is only our second day with finding factors, we're still working together, but you have to take those steps to become better without Miss Kohler. I will not be there the rest of your life, so it's on you guys to try and remember this the best you can too with my help. So, find that factor. So I have to count by 7s until I get to 28, as close to 28. Let's have some fun and sing along to 7, 14, 21. 28, stop, because there's where the number is. So it was a 4. Woo! That was easy. Now, is 10 a factor of 28? Well, let's look at all the 10s. If 10 is a factor, that means we would be counting by 10s to get there. So let's go ahead and count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And I'm going to stop there. There are many more. Well, 28 is not on this list, but let's look at every number on this list. 0, 0, 0, 0, 0, 0. What do all the numbers end with? A 0. So since 28 does not end in a 0, it is not divisible by 10. 10 is not a factor. It also does not end in a 5. So 5 cannot be. But since these end in a 0, they are divisible by 10s and 5s. But moving on. Alright, so here we go. We're coming a little bit more independent. Sorry, my dog is being super loud in the background. Is 3 a factor of 54, and how can we find out? Well, there's multiple ways. We can do 1 and 54, and we can set it up like that table that we've had. And if we doubled this to 2, we would have to half this. And I'm going to help you out. It would be 27. I know that's very hard. Miss Kohler learned her doubles and halves by doing this a lot. Alright, well, I can't double again because this is an odd number. But I can notice that 27 is a factor of 3. So I can do 3. Don't know why I'm putting a 3 over here. Hold on. There we go. Because I know 7, 14, 3, 6, 9, 12, 15, 18, 21, 24, 27. Which would give me 18. And I know you're thinking, Miss Kohler, there is no way. Here's your hint. Divide. Miss Kohler can divide in her head. You guys are getting there. I know you guys are really smart. Another thing. These two together equal 9. So therefore, I know 9 is a number. And if 9 is a number, 6 is, because I can go use my 9s trick, which I can't really show you on the computer without my camera on. And those are my factors of 54. Now the question here says, if you divide and get a remainder, is it a factor? Remember, our definition of factor is it has, and composite means the number has to be a whole number, so this is a whole number, it doesn't have a part, has to be divided evenly into the groups. If it has a remainder, there's no way it was divided evenly. There was something left over. So the answer to this is going to be no. How can we find out? We can always divide. But there are some more tricks we're going to learn on the way. So we already learned our 5s and our 10s trick. We can learn our other tricks too. So here are some of those patterns we also refer to. Ones that we have already gone over. 2 will be a factor when the number is even. We knew that. 5 will be a factor when the number ends in 5 or 0. We've gone over that one. 10 will be a factor when the number ends in 10. We've gone over that. So ones that we haven't gone over yet that are going to be really helpful for easy today. Don't write this down, guys. We're going to be going over this more and more. Don't write it down. We will write it down the day that we know them all and we have practiced them all. But we've done 2, 5s, and 10s. And we're going to do 9s and 3s today. And that's going to be it. 3 will be a factor when you add up all the digits and it's a multiple of 3. So those 3 songs we sing, 3, 6, 9, 12, if you add up the number, the digits, and equals one of those numbers, it's a multiple of 3. And it's the same thing with 9s. If you add them up and it's a multiple of 9, so when we do our easy 9s finger finding, then it's a multiple of 9. So Use division to find out if 3 is a factor in the following numbers. We're going to use division, but we're also going to see if my pattern worked. So 78 divided into 3. I'm going to do long division for this one, and then I'm going to do place value and area. So say 3 as many times as you can until we get as close to 7 as possible without going over. 3, 6. So I'm holding up a 2. There's my divide. Multiply and subtract. Bring it on down and bring it on back. So that's where we would divide by 3 again. 3, 6, 9, 12, 15, 18. Divide, multiply. So it'd be 6 times 3 equals 18. Subtract. Nothing to bring down, so nothing to bring back. So it went in evenly. So 3 is a factor of 78. Put a little check mark here. Alright, next thing, place value for 87, 10s and 1s. I need 3 groups because we're trying to see if 3 is the factor. So the first thing I do would be 8. 1, 2, 3, 4, 5, 6, 7, 8. These two are uneven because it makes the rest of them uneven. Well, if this is worth 10 and this is worth 10, these two are worth 20 together. So I'm going to count them over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Alright, remember we said they're allowed to be uneven because at first when we do our tens column or our tens place, because we still haven't done our ones place value. So we have 5, 7, 5, 7, but 6. So we're going to start off here. 1, 2, 3, 4, 5, 6, 7. Alright, well they all went in evenly. So 1, 2, that equals 20, not 2. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, which gives me 29. So that went in evenly. That was nice. And the last one's 94. Well, we already figured out these. Remember if I said if we add the digits of the number and it's a multiple of 3, which means we say it in the song, it's a factor. So let's make an educated guess. Well, 7 plus 8 equals 15. When I sing my 3 song, do I say 15? 3, 6, 9, 12, 15. Yep. And it worked out. What about this one? 8 plus 7. Well, it's the same thing. It's just a reverse fact family. It's 15. Did it work out? Yep. What about 94? Let's make an educated guess with 94. So I'm going to add 9 plus 4 equals 13. Do I say 13 when I sing my 3 song? 3, 6, 9, 12, 15. No, I don't say 13. So it shouldn't work. So let's double check to make sure. Alright, what was the other? Area. We'll do our area method now. Go ahead and do this. We're dividing by 3. Well, I know 30 would be 1. That would give me 10. 30 would be another one. 30, 60, 90. 30, 60, 90, and then there would be a 4 right here. So that would give me 10, because 3 times 10 is 30. 3 times 10 is 30. 3 times 10 is 30. But wait a second. I could only get a 1 out of here with a remainder of 1. So I would have 31 remainder of 1. So it didn't work because it has a remainder. So that sheet that we learned today, if you add these numbers up, and it's one of the songs in 3, 6, 9, 12, 15, 18, then we know that it's a factor of 3. Alright. So we're going to do this one time. It's the associative property. It means you can mix things up or break things apart and it's still going to equal the same. So what this is saying is 42 equals 6 times 7. But I know I can break that 6 down because it's a composite number into 2 times 3. So that's it. There are no more for this one. But I can do 42 equals 2 times something. Because it's an even number, it has to be by 2. Let's try 2 times 21. Well, I know I can break that 21 down because that's part of my 3 song. So that would equal, the 2 would stay the same, the times would stay the same, but we're going to break down this 21 into 3, 6, 9, 12, 15, 18, 21, 7. Isn't that funny? These numbers are all right here. 2, 3, 7. That's interesting. And I know, and 4, we already knew that since this is an even number, we get our 2 from here. But if 4 plus 2 equals 6, and 6 is in my 3 song, I should find a 3, right? There it is. Alright. So, explain your thinking or use division. You don't have to do both. That's what's awesome. So let's look at, this is in your math journal, this is problems 1A and 1B. Is 2 a factor of 84? Well, we know that if it's a factor of 2, the number has to be even. Is 84 even? Let's look at that digit. 4. 4 is an even number. And I'm going to put right here, yes, because 84 is an even number. I'm going to shrink that a little bit. There we go. I'll make it bigger now. What about, is 2 a factor of 83? Well, let's look at that. If it's, I'm looking at 2, I'm looking at this ones place. Is 3 even? Nope. So I'm going to end up typing no, because 83 is an odd number. That was fairly easy. I just need to get my answer up here. There we go. That's it. So you're going to try your best on the rest of the problem set. Try and get all of 1 done, and if you get all of 1 done, keep moving on. I am going to be super awesome and leave this up on your screen, so if you hit pause, you can use this. Yay! I know, Miss Kohler's awesome. So you can either choose to prove it with division, or you can prove it to see if this works. Alright guys, good job. If you have any questions, please raise your hand. I know this was a lot of information today, and you guys have done super awesome.